We're going to focus on dividing polynomial functions using synthetic division. So let's start with this example. Let's say we have x cubed minus 2x squared minus 5x plus 6. And let's divide it by x minus 3 using synthetic division. How can we do this? Well, first, let's draw this. On the inside, you want to put the coefficients of this function. So it's 1x cubed minus 2x squared minus 5x plus 6. Now, you need to put a number here. What number do you think goes in that region? If you take this factor, x minus 3, and if you set it equal to 0 and solve for x, you'll see that x is equal to 3. That's one of the zeros of the function. At least sometimes it's a 0. But basically, if you see minus 3, reverse it. So in this case, we're going to use positive 3. So let's bring down a 1. 3 times 1 is 3. Negative 2 plus 3 is 1. And then multiply. 3 times 1 is 3. And then add. So you're going to multiply, add, and keep doing that. Negative 5 plus 3 is negative 2, and then multiply. 3 times negative 2 is negative 6. And the remainder is 0. If the remainder is 0, that means that this is a factor of this function, which means 3 is one of the zeros. If you don't get a 0 here, then this is not a factor. It's not factorable by x minus 3. But if you do get a 0, this function is factorable by x minus 3. So something to keep in mind. So what does this all mean? Now, x cubed divided by x is x squared. So the first number is the coefficient for x squared. So we have 1x squared and then plus 1x with a constant of negative 2. And so this is the answer. X cubed minus 2x squared minus 5x plus 6 divided by x minus 3 is equal to x squared plus x minus 2. Now let's try another example. Let's take x cubed plus 5x squared plus 7x plus 2. And let's divide it by x plus 2. So for the sake of practice, go ahead and try it. Feel free to pause the video. So if you set x plus 2 equal to 0 and solve for x, you'll get negative 2. So let's put that number out in the front. And the coefficients for this polynomial expression is going to be 1, 5, 7, and 2. So let's bring down the 1. And let's multiply. Negative 2 times 1 is negative 2. And then add. 5 plus negative 2 is 3. And then multiply. Negative 2 times 3 is negative 6. And 7 plus negative 6 is 1. And then negative 2 times 1 is negative 2. And 2 and negative 2 cancel. So once again, we have a remainder of 0, which means this expression is factorable by x plus 2. So the answer that we're looking for, it's 1x squared plus 3x plus 1. So this is the solution after you divide by these two expressions. After you divide by these two expressions. Now let's move on to our third example. 3x squared plus 7x minus 20 divided by x plus 5. Go ahead and divide these two using synthetic division. So first, let's set x plus 5 equal to 0. So if we subtract both sides by 5, we're going to use negative 5. And the coefficients are 3, 7, and negative 20. So let's bring down the 3 first. Negative 5 times 3, that's negative 15. And then 7 plus negative 15 is negative 8. And then negative 5 times negative 8, that's positive 40. And negative 20 plus 40, that's 20. So this time, the remainder is not 0, it's 20. So this expression is not factorable by x plus 5. Nevertheless, we can still divide it. So after we divide these two functions, or these two expressions, what do we get? 3x squared divided by x is 3x. So this is not going to be 3x squared, this is going to be 3x, and then minus 8. Now, if you have a remainder that's not 0, what do you do with it? It's going to be the remainder, 20, divided by what you tried to divide it by, which is x plus 5. So 3x squared plus 7x minus 20 divided by x plus 5 is equal to this expression, 3x minus 8 plus 20 divided by x plus 5. So that's what you need to do if you don't have a remainder of 0. You need to add r divided by whatever you try to divide it by, plus 6x minus 8 divided by x minus 4. Now this one is a little different than the last three problems. So go ahead and try this problem, but be careful. So once again, if we set x 0, if we add 4 to both sides, x will equal 4. So let's put a 4 on the outside. Now what are the coefficients that we need to write for this problem? Now if you put 7, 6, and negative 8, you won't get the answer right. When you write the polynomial function, you need to be aware of 0x squared. So you need to write this in descendant order. The 0 is very important. So it's going to be 7, 0, 6, negative 8. So if you forget this 0, your answer will be different than what it should be. So let's bring down the 7. 4 times 7 is 28. And 0 plus 28 is 28. Now 4 times 28. 4 times 20 is 80. 4 times 8 is 32. 80 plus 32, that's going to be 112. And 6 plus 112 is 118. Now, 4 times 118. So 4 times 100 is 400. 4 times 10 is 40. And 4 times 8 is 32. So 40 and 32 is 72 plus 400. That's going to be 472. And negative 8 plus 472 is 464. And so that is the remainder. Now, 7x cubed divided by x is 7x squared. So that's going to give us the first term. It's going to be 7x squared, and then plus 28x, plus a constant of 118, plus the remainder of 464, divided by what you tried to divide it by, x minus 4. So this is the final answer of the problem. Now let's work on one more example. 3x to the fourth minus 5x squared plus 6 divided by x minus 2. It's very similar to the last example, so for the sake of practice, pause the video and try this problem. So let's set x minus 2 equal to 0. So adding 2 to both sides, x is 2. Now keep in mind, don't forget about the 0x cubed and also 0x. So there's two zeros that we have to deal with in this synthetic division problem. So we have 3, 0, negative 5, 0, and 6. So let's bring down the 3. 2 times 3 is 6. 0 plus 6 is 6. And then 2 times 6 is 12. Negative 5 plus 12 is 7. 2 times 7 is 14. 0 plus 14 is 14. And then 2 times 14 is 28. 6 plus 28 is 34. Now, 3x to the fourth divided by x is going to be 3x cubed. So let's bring this down. This is going to be 3x cubed, and in descending order, the next one is going to be 6x squared plus 7x plus 14, and we have a remainder of 34. So it's going to be plus the remainder divided by what you tried to divide it by, x minus 2.